Hello, and welcome to another episode of Physics Chat. Physics Chat is a show where we talk to real-life scientists and ask them the questions about what it's like to be a modern-day physicist. We talk about everything from their research to the things that they are passionate about. But you know I couldn't do this alone. Joe and Nathan are back with me, and we're ready to do some more chatting. On today's show, we have a physics PhD student and a personal friend of mine from the University of Cardiff. Hello, Luke. How are you doing?
Hi, Susie. Hi, everyone. I'm doing really well, thanks. And thank you for inviting me on. It's a pleasure to be here.
Oh, you're absolutely welcome. I know you love hiking and nature. So what is the last place you have been able to explore?
The other week, I was fortunate enough to go to Northern Ireland, visited places like the Giant's Causeway and the Mourne Mountains. It was absolutely fantastic. Lovely to be sort of outside the city and just take a little bit of a break away from everything. Really, really stunning views and a lot of hiking. Probably about 9 or 10 miles a day.
Oh my word, I don't know how you do that. Thank you so much again for being on the show, but could you tell me what you're researching, please?
I'm actually doing sort of 2 or 3 various connected research themes at the moment. My primary research theme is on gas giant planets, so a little bit like Jupiter or Saturn, but slightly warmer. And these are places where they kind of exist in what's called the habitable zone, the area where we might get liquid water on their surfaces if they had surfaces. Obviously, these ones do not. And I'm trying to see whether or not we can observe these types of exoplanets, exoplanets being planets that just orbit other stars, and really just, see what we might be able to find out about them with upcoming and future missions. Things like Twinkle and ESA's M4 mission Ariel.
Wow, there's loads of impact there, which sounds great. So I guess we should start pretty basic for my benefit as much as anyone else. How do planets form in the first place is what we're going to start with.
The way planets form is a little bit unknown. We've got some good theories, but we've never directly observed a planet form. What we think happens is when a star forms, there is a disk of dust, metals, and gas that typically forms around it. So if you think about Saturn and its rings, it's a similar kind of structure to that. And over time, some of those dust grains and those metals, they collide with each other. And as they collide, they obviously get bigger. Now, bigger objects, they have a stronger gravitational pull. These stronger gravitational objects then attract more and more material. And slowly you build everything up. A little bit like if you had a snowball and you started putting more snow or throwing more snow onto it, that would build up. And that's basically how planets get bigger and bigger. We think that rocky planets like Earth and Mars, we think that they form quite close to their star. And so there aren't a lot of gases for them to gather. But the bigger planets, the gas giants, things like Jupiter, Saturn, and other hot gas giants that exist around exoplanets, we think they form further out beyond what is called the ice line.
That's really interesting. It's obviously a little bit harder to detect planets outside of our own solar system. Can you maybe tell us a little bit about how we go about detecting these?
I think there's something like 8 to 10 methods by which exoplanets have currently been detected, but about 90%, possibly even 95% of exoplanets have been detected by 2 separate methods. The first of this is called the transit method. So this method, if you imagine you have a light bulb and you pass something small in front of that light bulb, the total amount of light that you see gets a little bit dimmer. And if that happens repetitively, on very even timescales, then we use that to infer the presence of a planet. And that has detected something of the order of about 4,000 to 5,000 exoplanets to date. We know of about 5,500. The other method, which is really, really important, is something called the radial velocity method. When a planet interacts with its star, it will cause it to wobble very slightly, not by much, and we can actually detect those little wobbles. And again, when it happens on a regular basis, we can infer the presence of a planet. The other method that I will say that is gaining a lot of traction at the moment is something called direct imaging. And here what we do is we try and block out the light from a star, and we actually see the reflected light coming from very hot, very young planets. This method is really, really interesting and really quite promising. But as with all of these 3 methods, they are very, very challenging.
Oh, that sounds so cool. So can you tell me why gas giants are so interesting and why we want to observe them?
Of course, yeah. So gas giants, in my opinion at least, are very interesting planets. Okay, They might not have life as we would expect to find it, which is on, a rocky-based planet with probably water. But we don't know a lot about their interiors. Obviously, we see a lot of clouds, but do they have surfaces deep down? Are those surfaces even solid? Are they made of rocks and metal? We don't know. Maybe there's some sort of weird state of liquid, and really there could be anything in between. So trying to understand these planets, and particularly how those planets might change depending on how far out from their star they are, how cold they are, is really, really important. And that can help us understand our own atmosphere and the dynamics that has. But it can also possibly be a place that we might be able to search for life. Now, that sounds a little bit weird, right? We think of life as having to be on some sort of rocky planet, something with water, something that people could stand on or could swim in. Well, the chances are is that might be true, but we only have Earth to base this all off. And we know that there are microbes, there are small, tiny life organisms that exist in clouds on Earth. So maybe, if we had water clouds on a gas giant exoplanet, there might be some way that some small microbes may be able to live in the atmospheres of those planets. Now, to me, that is completely alien. It's very, very strange, and it's not at all like what we see on things like sci-fi. But it goes to show just how ingenious humans can be of coming up with ways that maybe we might be able to look for and find other types of life.
Yeah, that's so interesting to hear about. I definitely never heard anything like that. I guess going back to, you mentioned how, we have our own example of what Earth is like with plenty of water and all the life we see. How common are exoplanets that are like our Earth then?
So that's a little bit difficult to answer. I think the number of what we call terrestrial planets, roughly Earth-like planets, is in the couple of hundreds. So that's going to make up maybe sort of 4 to 10% of known planets. However, of all of these, the number that are actually like the Earth, so are in the right kind of temperature conditions, have a similar density, have a similar mass and radius, it's a lot harder to say. Trying to take those sorts of measurements can be really, really challenging. But on top of that, we don't know whether or not the planet or these planets are going to be like Earth, or perhaps like one of Earth's twin sisters, if you like, Mars or Venus. But yeah, so coming back to that question that you asked, how common are planets like the Earth? It's we're waiting to see. And one of the ways that we are going to be able to explore that is to start looking at the atmospheres of these types of planets and see what kind of molecules we can see. If we can see stuff like water, like oxygen, like nitrogen, an atmosphere that might be a little bit like the Earth, then that would be really, really promising and very, very interesting for future studies.
And I guess it's quite difficult, really, that, as you say, we only have the example of Earth for what life is. But then you were talking about the gas giants, where there might be something we're kind of not used to. I guess you talk a lot about microbes, and we have that example. What do you think the chances are of finding some intelligent life or aliens on one of these other planets?
I think that one is a really, really tough question to answer. I would love to think that somewhere out there, whether it's on a planet that we've already discovered or one that is even further out, there would be some form of intelligent life, some alien life. I think that's almost certain. Whether it's on one of the planets that we have discovered, who knows? There's lots of kind of conflicting theories. We've never really seen any kind of technological signals. But that being said, we've only been able to kind of make those technology signals in the last 50 to 100 years, maybe 150 tops. And that is not a very long period of time. You would have to have another civilization that was also looking at the same time and sending those signals at the same time. So there's so many different questions, and it comes into play with things like, how long do civilizations last for? How long do intelligent civilizations last for? Taking a slightly pessimistic view, if you look at Earth and the human civilization, it's not unlikely that through our own effects on this planet, whether it be nuclear war, whether it be climate change, we may suffer as a species and our technological capabilities may diminish. And at that point, will we still be sending signals out into space? Who knows? Or will we have more pressing concerns by trying to keep our own species and our planet alive?
That leads really nicely into my next question, actually, which was obviously the situation on our planet. You've talked a little bit about. What do you think about moving to Mars? Is that a possibility? Obviously, we've had the recent and not so successful launch of SpaceX, the Starship. Do you think that there might be a chance in the future that we could live there?
I think it's definitely possible. And there's been a lot of theoretical work that has gone into trying to understand whether or not it'd be possible to set up colonies on other planets, be this Mars or even possibly a colony on the moon. Mars at the moment is incredibly challenging to live on. As I said, it's got virtually no atmosphere, which means that if you or I were to stand on Mars with no protection at all, we would implode. And that's really not very pleasant. But that being said, we think that the soil that exists on Mars could be used to grow crops. And if we were to somehow be able to thicken the atmosphere, and there are a number of different ways that have been suggested to do that, then maybe it might be possible to melt the polar ice caps of Mars to introduce water onto that planet again. Then there's no reason to think that we couldn't potentially make Mars somewhat Earth-like. But that's not the only kind of thing that we might be able to do. There have been ideas for constructing very elaborate sort of domed cities on Mars, whereby effectively you're closed in. And so you only have to make that little bubble inhabitable. And then you've got things like the ideas that come from The Martian, where you have small enclosed man-made habitats that are either on the surface or actually preferably that are burrowed into the Martian rock. So yeah, I think it's definitely possible to live on Mars, but it is going to take a lot of human ingenuity, a lot of courage, and a lot of bravery by anybody going there to be able to make that possible.
That leads me nicely onto my not so random question. If you could take 3 things to Mars, what would you take and why?
So for this part, I'm going to throw the question back to you a little bit here, Susie. What condition is Mars in at this time?
Oh, that's a very good question. I think we'll go for the domed cities.
Domed cities, okay. In that case, I think my number one item would definitely be a camera. I think there would be some fantastic sights that you could see, and being able to photograph those and send those back to Earth to really inspire people, to show people what it was like to live on another planet. My second thing would be, I guess this might be cheating a little bit, but family. It'd be lovely to take along a family member, if not more. And if that one is cheating, then I'll say maybe a pet. A cat or a dog would be fantastic. Again, some sort of companionship I think would be brilliant. The last one, and it sounds a little bit cliche, would be some music.
I think that's probably a really good answer, but maybe slightly less lonely than The Martian if you have your family with you. So the ideal situation. Maybe go into a little bit of detail about what the future is for exoplanet research.
The future at the moment is looking incredibly bright. We've already got, as I said, about 5,000 to 5,500 known exoplanets. There are still missions that are trying to detect even more. And we have another roughly somewhere between 7,000 and 10,000 candidate planets. So these are data that we have taken that we think show signs of there being an exoplanet around a star. But we're not yet 100% sure, so we don't want to say there is definitely a planet there. So it looks like those numbers are going to keep on increasing, and that's going to be really promising for the exoplanet community. But going beyond that, we've seen James Webb, which is a fantastic, somewhat new telescope, and that is going to be able to explore the atmospheres of individual planets in a lot of depth, a lot of detail. We're going to be able to get a lot of information about what is in those atmospheres. Is it stuff that is breathable atmospheres? Or are they things that we definitely couldn't breathe but are nonetheless exciting? Maybe things like molten metals in the atmosphere. So if you were to stand on that planet's surface, you would actually see it raining metal. There's also a couple of missions, which I've already mentioned so far, called Twinkle and Ariel. And they are going to be doing very similar things to James Webb, except they're going to be survey missions. Their primary goal will be to look at somewhere between tens and hundreds, possibly even up to a couple of thousand exoplanet atmospheres, ranging from things like gas giants all the way down to these rocky planets and everything in between.
Yeah, so we've been looking into the future. It's been really exciting for exoplanet research. But have you got any advice that you would give to your child self?
For sure, yeah. And I think the simplest take home is explore. Take those opportunities, whatever they might be, to find out what you love in life. At the end of the day, I absolutely love the research that I'm doing. And that means that really, I never feel like I work that hard because it's something that I want to do. I remember back in year 3, so I would have been around about 7 or maybe 8 years old. And I got the opportunity to look through a telescope. Somebody lined that telescope up for me, and I was able to see Jupiter, and I was also able to see Saturn and its rings. And for me, that was incredible. I could see another planet with my own eyes, with the aid of this telescope, of course. And it just absolutely, I got the space bug after that. And I'll be honest, that's never gone away. But without that, if I'd never done that and taken that opportunity, would I have still followed the path and got to where I am today? I don't know. Maybe I would have done, maybe I wouldn't. But yeah, just take every opportunity as it comes because you never know where an individual moment might lead you.
Oh, that's such amazing advice. Take every opportunity. Thank you so much for being on Physics Chat. It's been so lovely having you. And let me get to my script. I hope this encourages you to go out and explore as much of our universe as possible. Let us know in the comments section what 3 things you would take to Mars and why. We would love to hear from you, so keep writing. Anyway, from everyone at Field of View, we hope you have a great day and goodbye. Bye.
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 Explore. Take those opportunities, whatever they might be, to find out what you love in life.